Hello everyone, welcome to my channel Enthusiasm. This video is day 29 of the 30-day challenge. It is all about integration by parts. Let's check it out. Integrate e to the power of x times bracket 1 plus sine x over 1 plus cosine x dx. First of all, we have to decide which term should be absorbed into the differential. Because e to the power of x is exponential function e, while the fraction is trigonometric function t. By the Layard's rule, t is in front of e, so t is u and e is dv. In other words, we'll have to absorb e to the power of x, that is to integrate it. Therefore, the integral is equal to integrate bracket 1 plus sine x over 1 plus cosine x, the bracket e to the power of x. Comparing with the formula of integration by parts, u is equal to the fraction and v is equal to e to the power of x. The first term is a product e to the power of x times bracket 1 plus sine x over 1 plus cosine x. The second term is the integral by swapping u and v, which is integrate e to the power of x, the bracket the trigonometric function. Let's focus on the differential. We have to differentiate 1 plus sine x over 1 plus cosine x. Here we apply the quotient rule. It is shown right here. Therefore, the derivative is equal to 1 plus cosine x times cosine x minus 1 plus sine x times negative sine x all over 1 plus cosine x whole square. Expand the terms in the numerator, we have cosine x plus cosine square x plus sine x plus sine square x. Adding up cosine square x and sine square x, we get 1 plus cosine x plus sine x. At this point, how do we continue? We're going to use a special trick. You see, there is 1 plus cosine x in the numerator. This is the same as the term in the denominator. Let's separate it into two parts like this. Then we get a simpler form, 1 over 1 plus cosine x plus sine x over 1 plus cosine x whole square. In other words, the differential is equal to these two fractions times dx. Let's put the result into the integral like this. Now, we can separate it into two integrals at the back. What can we do next? Well, let's do integration by parts one more time. The first integral is simpler. Let's go ahead with this one. We absorb e to the power of x into the differential. Then the integral is in the form integrate u dv, where u is equal to 1 over 1 plus cosine x, and v is equal to e to the power of x. Using integration by parts, the first term is equal to negative e to the power of x over 1 plus cosine x. The second term is the integral by swapping u and v again, which is integrate e to the power of x, the bracket 1 over 1 plus cosine x. Be careful about the sign of the integral, because we have a negative sign in the step above. Another negative sign is from integration by parts, so two negatives give a positive. For the last integral, we shall take care of it in a second. Now, we have to differentiate 1 over 1 plus cosine x. This one is relatively easier. Let's write it as 1 plus cosine x to the power of negative 1. Using chain rule, then we have negative bracket 1 plus cosine x to the power of negative 2 times bracket negative sine x. This is equal to sine x over 1 plus cosine x whole square. Do you recognize something special? We put the differential into the integral like this. Great! It's so fortunate that these two integrals are exactly the same, but they have different signs, so we can cancel them out. For the remaining two terms, they have the same denominator, 1 plus cosine x. We can put them together in a single fraction. Cross out the constants 1, then we get the answer. It is equal to e to the power of x times sine x over 1 plus cosine x plus c. It comes to the grand final of this series. This is probably the most challenging question of integration by parts that you have ever come across. Go check out this integral on day 30. The link is on the screen. I will see you there.